The DNA is a new digital phase noise test system developed by NoiseXT. The DNA is the latest in phase noise measurement systems developed by NoiseXT beginning over 40 years ago. The DNA is designed to be used as both a development tool and a high-speed production test instrument. Simply connect the output of the signal source to the DNA RF input, and then press the Start key. Initially, the DNA analyzes the signal, determines the input RF frequency and the power level, and then it begins the measurement. The results are displayed in about 10 seconds, and the system continues to process the signal and increase the accuracy of the results. The DNA uses cross-correlation to improve the noise floor of the measurement for more accurate device results. The test is simplified since there is no need for external tunable oscillators for references. The system will display the entire offset range immediately. It is not necessary to wait for the system to measure each offset decade separately before results are displayed. The system also optimizes the number of cross correlations for the specific device under test, in this case a 10 MHz crystal oscillator. The optimization will correctly assign cross correlations to each offset decade. The x-axis shows the frequency offset from the carrier, while the y-axis shows the phase noise level in dBc per hertz. The grayscale shows the system noise floor. The system noise floor will continue to decrease as the number of cross correlations are executed. The system also displays the frequency and power level of the device under test, as well as the internal or external references. If an external reference is used, it need not be tunable or at the exact frequency of the device under test. Many changes to the measurement and display may be made using the display touchscreen. A single touch allows the user to change the scale for both axes. A double touch returns the system to full scale. Touching and holding the screen brings up the full display menu. The user may display either phase noise, Allen variance, or fractional frequency noise display. Measured data may be output from the system using a number of formats. Going to the utility screen and pressing File brings up some of the options. In the Measure Save mode, the entire measurement is saved in a proprietary format that can be recalled and displayed later. In the Print mode, a report title may be added, along with information about the device under test. The display background may be changed from dark to white. Legends can be turned on and off, along with markers, cross-correlation table, residual measurements, and also comments may be added. This can then be saved to a PDF file or printed out to a printer that's connected to a USB port. From the File menu, measurements can be saved and used for display later for comparison purposes. Up to 20 measurements can be saved and displayed at the same time. There's information on the device that was tested, as well as the references, whether they are external or internal. The user may enter a file name and store this file like any other Windows-based file. Markers may be added to the trace. All markers can be added with a single touch. The default places the markers at each decade. Individual markers may be moved using the touchscreen. When the marker is moved, there will be a change in the displayed output. They also may be shut off and turned on individually. From the Settings menu, either the measurement or the display may be selected. The measurement is selected. All of the parameters can be established, and smoothing may be added to any of the displayed traces. In the display mode, either a light or dark display may be made, and legends can be turned on and off. The user may also display the Allen variance plots, both the residual plot and the plot of the device under test. Measurement stability over time again can be assessed by looking at the fractional frequency plot. So variations in this plot would indicate an unstable measurement. In addition to local control, the system may also be controlled remotely with TCP over IP Ethernet connections. A set of ASCII commands are supplied with the system for user-created scripts. From the Measure menu, spurs can be shown. Spurs may be either displayed, printed separately, or printed with the phase noise trace. In any case, all of the measurements, Allen variance, phase noise, spurs, frequency stability, all of those measurements are made at the time the phase noise measurement is made and stored. And the user is given the flexibility to either display those plots or suppress them. The following charts show the baseline system noise performance under different conditions.